Alright, so now we're on day 31. These are some basic probability rules. A probability is any number between 0 and 1. That is, for any event A, like flipping a coin, rolling a die, the probability of A, this is read probability of A, is somewhere between 0 and 1. Remember that probability is a relative frequency, so in other words it can be written as a fraction or a percent. We cannot have more successes than the number of trials. So the probability of A is always less than or equal to 1. And we cannot have a negative number of successes. So the probability of A is always greater than or equal to 0. If an event has a probability equal to 0, it will never occur. If the probability has an event is equal to 1, it has to occur. So something has to happen. That is, when we consider a single trial of a random phenomenon, one of the possible outcomes must occur. For example, if we're flipping a coin, we must either get heads or tails. All the possible outcomes of a random phenomenon are called the sample space. Sample space, or S. Thus, the probability of getting all the sample space is 1. If we add the probabilities of all the possible outcomes and it doesn't equal 1, then the assignment of probabilities is not legitimate, or there might be a rounding error. The probability of an event occurring is 1 minus the probability that it doesn't occur. That is, the probability of A is 1 minus the probability of A complement. This little A with a C is read A complement. The complement is the probability of something not happening, or the opposite. So if the probability of rain today is 0.1 or 10%, then the probability that will not rain today is 1 minus 0.1 or 90%. The event not A is usually called the complement of A and is denoted A with a little C above it. Other books may use different notation, including A apostrophe, tilde A, etc. So for two disjoint events, A and B, the probability that one or the other event occurs is the sum of the probabilities of the two events. This is really important. It tells you exactly what to do, and then here's a rule behind it. That is the probability of A or B happening. So like the probability of if I roll a die, I get a 2 or a 6, is the probability of A, that little U, this thing means union. This is a set notation for union, meaning put together. So the probability of A plus the probability of A. If A and B are disjoint. So here's an example of disjoint because we used it twice up here. Two events are disjoint if they do not share any outcomes. For example, suppose you randomly selected a registered voter and asked him which political party he belonged to. Since you can only register as a member of one party, being a Democrat and being a Republican are disjoint events. You cannot be both at the same time. That's what I always kind of ask myself. Can I do both things at the same time? If I can't, then it's disjoint. So disjoint events are also called as, another name for disjoint events are mutually exclusive. So if the probability of being a Republican is 0.4 and the probability of being a Democrat is 0.45, the probability of being a Republican or a Democrat is, all right, so the probability of being a Republican or a Democrat would be the probability of R union D, which is the same as the probability of being a Republican plus the probability of being a Democrat. So the probability of being a Republican, they told me right here, probability of being a Republican, they said, was 0.4. The probability of being a Democrat was 0.45. So the probability of being a Democrat or a Republican is 0.4 plus 0.45, which is 0.95, which leaves 5% other. So this rule also works for more than two disjoint events. For example, if the probability of being a libertarian is 5%, then the probability of being Republican or Democrat or libertarian would be the probability of being Republican plus the probability of being Democrat plus the probability of being libertarian, which would be equal to 0.4 plus 0.45 plus 0.05. 5% written as a decimal, which is 1. So you cannot use this addition rule when the events are not disjoint. For example, for students in statistics, just think of in this class, the probability of being a senior is 75%, 0.75, and the probability of owning a TI is 90%, but the probability of a senior with a TI or owning a TI is not equal to 0.75 plus 0.9. Why not? Because that gives you 1.65, which is greater than 1, so it's not legal. And if you think about it, can you be a senior and have a calculator? Can you be a senior and have a calculator? I think the answer is yes. So these are not disjoint events. Okay. All right, so for two independent events, the probability of A and B occurring, the probability that both occur, is the product of the probabilities. So this is another rule. So is the product of the probability. So the product of A and B happening is the product of A. This little thing means intersect. Both happening at the same time. Both at the same time is equal to the probability of A times the probability of B if the events are independent. Recall from the last day's notes that two events are independent if knowing the outcome of one event does not change the probability of the other event. For example, if we flip a coin and roll a die, the event heads and 6 are independent. Since if you flip a coin, that doesn't affect rolling the die. So since knowing the outcome of the coin flip does not change the probability the die lands on 6. So thus the probability of heads and 6 would be the probability of heads times the probability of getting a 6. So the probability of getting a heads is 1/2 of the time. The probability of getting a 6 is 1/6 of the time. 1/2 times 1/6 is 1/12. All right, so this rule also works for more than two independent events. So for example, the probability of rolling 3 6s in a row is the probability of 6 and 6 and 6. So the probability of rolling a 6 times the probability of rolling a 6 times the probability of rolling a 6. The probability of rolling a 6 in the first time is 1/6. The second time is 1/6. And the third time is 1/6. So you multiply those and you get 1 over 6 cubed, and 6 to the third power is 216. So your probability is 1 over 216. Sometimes in your book they'll write that as a decimal, so they'll take 1 divided by 216 and write that the probability is 0.00463. All right, so you cannot use this multiplication rule when the events are not independent. So, for example, if a class of 30 students has 16 females, the probability of selecting without replacement 2 females is not 16 over 30 times 16 over 30. Instead, it would be when you select the first female, it would be 16 over 30 times the probability of getting the second female. Well, now how many females are in the room? There's 15 and there's only 29 people. So you can't just multiply you are multiplying the probabilities, but this you're taking into account that you've taken a person out. So in summary, when you want the probability of A or the probability of B, you add the probabilities. If they're disjoint, you can't be both at the same time. And when you want probability of A and B, you multiply the probabilities. There's a summary of everything we just covered. So now we want to find some probabilities here. So the probability of rain in Oro Valley is 50%, and the probability of rain in Marana is 50%. What is the probability it will rain in both places? All right, well, the main thing we want to look at here, let me get to the right page. The main thing that we want to look at here is, I'll just tell you, this is like saying Sioux City. This is like saying Morningside and Greenville. Okay. The probability that it's going to rain in both places, it's not really independent. If it's going to rain in Morningside, it's most likely going to rain in Greenville. So these are not independent. So we can't answer. All right, so if the probability of rain in New York City is also 50%, what is the probability that will rain in both Oro Valley? Oro Valley happens to be in Arizona or Colorado. I think it's in Arizona and New York. Well, that would be the probability of rain in NYC and in Oro Valley. That would be the probability of rain in NYC times the probability of rain in Oro Valley, since those are independent. Why? Because they're so far away. So this would be 0.5 times 0.5 or 0.25. So now we're just going to walk through a problem. It says, suppose that 50% of cars sold in this country are made in the USA, 30% in Japan, and 10% in Germany. Is this a valid assignment of probabilities? How do you know? Well, I have to look at, okay, so 0.5 are in the USA, and 0.3 are in Japan, and 0.1 are in Germany. If you add all those up, you only get 0.9. So it's not really a valid assignment of probabilities yet. All right, so how would I make that? Well, that would mean there's 10% that would be in other countries. So now part 2, it says, assume that the remaining 10% of cars are made in other countries. State the probability distribution of make of car. Note, a probability distribution lists all the outcomes of a variable and their probabilities. So probability distribution, our variable is X. This is the country of origin. And so the countries of origin are USA, Japan, Germany, and other countries. So the country of origin, we've got USA, there's 50%, 0.5, Japan, 30%, 0.3, Germany, 10%, other 10%. So there's our assignment of probabilities. It's our probability distribution. All right, so now moving to the top of the next page. What is the probability that a car selected at random is not made in the USA? All right, so the probability that a car selected at random is not made in the USA. All right, so the probability that it's not in USA, well, we learned earlier that the probability of not something is 1 minus the probability that it is in USA. So that would be 1 minus 0.5, so 50% of the time it's not made in the USA. Okay, what is the probability that a car selected at random is made in Germany or Japan? So the probability that it's made in Germany or Japan, or probabilities, as you recall, are added. So the probability that it's made in Germany plus the probability it's made in Japan, which is 0.3 plus 0.1, or 0.40. And I think I got those flipped around, but that's okay. Okay, this rule used in Part C works well for disjoint events. Why are these events disjoint? Well, they're disjoint because you cannot be made in, okay, or a car cannot be made in Germany and Japan. All right, so what is the probability that 2 cars selected at random are both from Japan? So probability of being from Japan and from being from Japan. So that would be a multiplication. So the probability of being from Japan times the probability of being from the second one being from Japan. So the first one being from Japan is 10% times 10% equals 0.01. The next video will finish up the rest of the note.